Hello guys, welcome back to VC Tech. Previously we talked about OSPF version 2, which is used for IPv4 networks. Today we are going to move a step further and talk about OSPF version 3, also known as OSPF version 6 or OSPFv6, which is designed to support IPv6 network. Because as the internet continues to transition to IPv6, it becomes important for network engineers to understand how dynamic routing works in IPv6 environment. In this video, we will explore the OSPF version 6, what it is, how it works, and how it differs from OSPF version 2. We will also look into practical configuration example so you can see how to implement OSPF version 6 on a router. I've already assigned IPv6 address to the interfaces on the router, and always remember, when configuring IPv6, it is necessary to always enable IP unicast routing before assigning IPv6 address to interfaces on the router. As we have over here, already configured the link local address as well as the global unicast address for all the interfaces on the router. Let's also get the IPv6 address. For this, we've gotten our IPv6 address and also our link local. Let's also get the second for this device. So we are able to get IPv6 address for this device. Let's move over to the second local area network and assign IPv6 address to the devices, and they both have both link local and global unicast address, as well as this device over here. We've not configured a routing protocol on any of the router, as we can check by just going to one of the routers. Let's get the IP address, IPv6 address of this device. So ipconfig, we get this global unicast address. And let's move over to this local area network and try to ping that device and see if we will be able to communicate with that device. As you can see, we are getting destination host unreachable. Let's also try to ping from the other device. Let's get the IPv6 address, global unicast address, and ping from this device, this local area network, and see what will be the response. As you can also see, we got destination host unreachable. Before we get into configuring OSPF version 6 on the routers, OSPF version 6 is a dynamic routing protocol that allows router to automatically exchange routing information in an Internet Protocol version 6 network. In a simple term to this, OSPF version 6 helps router to discover neighboring routers. It also shares network information, as well as it builds the network topology map. It also calculates the best path to a destination. OSPF version 6 also updates routes whenever the network changes. So since we know all that, let's head over and configure OSPF version 6 to enable host devices on the network communicate. So from this router over here, let's start our configuration for OSPF version 6. So we can do that by saying IPv6 router. This is where we specify what routing protocol that we are going to be using. So for this tutorial, we are going to be using OSPF. And we also need to specify the process ID. So we want to give this process ID to be 10. By doing this, we've enabled OSPF version 6 on that router. Let's also assign the router ID. This will be taking 1.1.1.1. So we are done with configuring the first step of OSPF version 6 on the router. Let's also head over to the second router and do the same configuration, and also on the last router before we do the final configuration for OSPF version 6, so the host devices could be able to communicate. So always remember that when configuring IPv6, we have to enable IPv6 global unicast routing, which is IP unicast routing. So this is very important. I've already done this previously, so do not forget to do it when you're configuring IPv6. So IPv6 router OSPF with a process ID of 10, we also want to specify the router ID of 1.1.1.2. And lastly, on this router over here, let's do the same configuration. IPv6 router OSPF, a process ID of 10, and we also want to specify a router ID of 1.1.1.3. So all the routers know what protocol that they are going to be using to carry out traffic from one local area network to another local area network. However, on OSPF version 2 for IPv4, we advertise all the directly connected network for host devices to be able to communicate. In IPv6, it is different. That is where the configuration for OSPF version 6 gets a bit tricky. Now, let's try to also ping. Since the routers know what protocol they are going to be using to carry out packets, let's also ping one more time and see if the configuration is active. Well, it's not, because we've not done this on the interfaces. So on IPv4, we advertise all the directly connected network to the router. However, for OSPFv6, we advertise the routing protocol on the interfaces of the router. So for OSPF version 6 to be active, we have to advertise it, or we have to let the interfaces know that this is the routing protocol that they are going to be using to route out traffic. So we head over to interface gig 0/0, and we see IPv6 OSPF with a process ID of 10 and area 0. So by doing this on interface gig 0/0, we've advertised a routing protocol on that interface. Let's also do the same configuration for the second interface, interface gig 0/1. So this is what we do: IPv6 OSPF with a process ID of 10, and we specify area 0. This router now knows how to send out traffic. They'll be using both interfaces to send out traffic to whatever neighboring router that they are connected to. So we are going to do the same configuration on this router also: interface gig 0/0, and we see IPv6 OSPF process ID of 10, area 0. And on the second interface gig 0/1, interface gig 0/1, IPv6 OSPF process ID of 10, area 0. And we are also going to do the same configuration on the last router. As you can see that this router over here, neighbor router of 1.1.1 1, which is this router. The router ID of this router is 1.1.1.1, and it does not form neighbor with the second router. Let's also do the same configuration on this router so our traffic could be able to go through. So interface gig0/0 IPv6 OSPF process ID of 10 area 0 and interface gig0/1 IPv6 OSPF area 0. What's that? IPv6 OSPF process ID of 10 area 0, and we should just let's wait a bit for this one to be connected. However, this router is connected to this router right here, and as you can see, the last router is also connected to router 1.1.1.2, which is this router. This router has also formed neighbor to 1.1.1.2. Now let's try to ping our host devices that we were trying to get to that was not reachable. However, since we've configured OSPF and also advertised our configuration on the interfaces for IPv6 network, the devices now know how to get to the device from a different local area network. Let's also ping with this device as we tried previously and we got destination host unreachable. Let's try that one more time. As you can also see, our configuration for OSPF version 6 is accurate, and as host devices can now communicate with each other. We can also check from the routers how to troubleshoot. So let's see on this router, let's check if the OSPF version 6 is running. So how we do that is we say do show IPv6 protocol. So what you can see is it is telling us that our routing protocol is connected, and we also have a process ID of 10, OSPF 10, that is our process ID, and this configuration is active on both interfaces, gig0/0 and gig0/1. As we can also check our OSPF neighbor. For this router, it is going to have just one neighbor, which will be 1.1.2. So do show IPv6 OSPF neighbor. As you can see, this is our neighboring router because it is the router that is directly connected to. Why, if we should do that same troubleshooting method on this router, it is going to show us that we have two neighboring routers. So do show IPv6 OSPF neighbor. It is showing us we have two neighbors, as this router is connected to it as well as this router is also connected to it. Now let's also check the interfaces that our OSPF configuration is active. Let's do that on this router. We say do show IPv6 OSPF interface. It is showing us that on this interface gig0/0, our OSPF is up, line protocol is up, as well as interface gig0/1, our OSPF protocol is also up. It has the router ID of 1.1.1 as well as the process ID. So this is how troubleshooting is done when configuring OSPF version 6. Understanding how to troubleshoot OSPF version 6 is very important, because in real world, networks routing problem can stop communication between networks. This command can help network engineers to quickly identify where the problem is coming from. In this video, we've explained what OSPF version 6 is, how it works, its key features, and how to configure it on a Cisco router. Understanding OSPF is very important as the network continues to move towards IPv6 infrastructure. If you find this video helpful, don't forget to like, subscribe, and also share this video, as I will be seeing you in the next video.